Unit 5, Operations with Fractions, Grade 7 Math. In order to do this unit, there's a few things to remember first. Remember how to write the equivalent fractions, or in other words, the same fraction? Well, let's take this here. I have 2, 4, 6, 8, 10, 12. So I have 12 here. I'm going to cut them in half, this group, and I'm going to shade in half of them. So I've got half out of 12, or out of two big groups, I've got one out of the two groups shaded in. Now, if I were to count these up individually, let's say the groups were not just one big group, it was made into groups of, oh, there we go, individual groups. So this is 1, 2, 3, 4, 5, 6 are shaded in out of 12. Okay, so it could be like that if I were to treat them as separate. If I were to put them in groups, say, of 2, I could have one group, 2 equal groups, 3 equal groups, 4 equal groups, 5 equal groups, 6 equal groups. So I have 6 equal groups, and I have 1, 2, 3 of them shaded in, as you can see there. So this is all the same. Okay, this is 1/2, 6 out of 12 is 1/2, and 3 out of 6 is 1/2. I could put them into other groups if I had a different number shaded and it work out nicely. Well, when you're writing an equivalent fraction, there's really an easy way to do it. And the simplest way to write an equivalent fraction is to just multiply the top number and the bottom number by the same amount. So let's look at this one for example. If I want to have something equivalent, a fraction over here, if I multiply the top by 2 and the bottom by 2, I'll end up with 6 over 8, which will be the exact same amount. Now if I were to multiply it instead of by 2, let's say I wanted to multiply it by 3, the top and the bottom, then I would have 9 over 12. So in other words, as long as you multiply the top and the bottom by the same number, they will always be equivalent or equal fractions. Okay? So if I take this one right here, let's say I want to go the other way. Let's say I would like to reduce this one. So in this case, I multiplied up here, but is there something that will go into 9 that will also go into 12? Well, I know 2 won't go into 9, but it will go into 12. How about 3? 3 will go into 9. Hey, and 3 will go into 12. So let's divide 9 by 3 and divide 12 by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So now we've just reduced our fraction to another equivalent fraction using division. So it's really easy to write an equivalent fraction, and it would have been something you would have done back in another grade as well. Now you can use a number line in order to find out equivalent fractions. I'm going to take these 3 number lines right here. And in this first one, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 1/12. This would be 2/12. This would be 3, 4, 5, 6, 7, 8/12 that this red dot is on. I have my next number line broken into 1, 2, 3, 4, 5, 6 equal pieces. So this first piece would be 1/6. This next piece would be 2/6, 3/6, and this one here would be 4/6, and this would be 5/6, and so on. The last one here has it broken down into 1, 2, 3 equal parts. So this first part being 1/3, 2/3, and this would be 3/3 or 1/2. So now all I have to do is look at this one. They're all the same right there. So these are all equivalent fractions. So we could test that by seeing, can we divide 8 by 2 and we'll get 4? Can we divide 12 by 2 and we'll get 6? So that divides them and shows that they are equivalent using a number line. Now let's look at mixed numbers and improper fractions, because that's something you need to remember from the beginning. If you look at this here number, I have 2 full blocks shaded in. That's why I have 2 whole. And then I have 1, 2, 3 pieces out of 5. So I have 2 whole and 3/5 of another one. Now if I want to change that to individual pieces, all I have to do is multiply 2 times 5 is 10, plus 3 more is 13. So there'll be 13 pieces, and remember they're fifths, so the bottom number always stays the same. So this is a proper fraction. Well, it doesn't call it proper, they call it a mixed. Okay. So it's mixed because it has a whole number and a fraction. So this one here is called a improper fraction. Now if you count the pieces up here, you should get 13/5. 1, 2, 3, 4, 5, and then another 5 is 10, 11, 12, 13. So let's take this one here on the bottom again. All you got to do is multiply 1 times 4 and then add 3 more. So 1 times 4 is 4, plus 3 more is 7. And remember, it's out of fourths. So it's pretty easy to change to a mixed, from a mixed number to an improper fraction. And if you wanted to change it back, all you say is, how many times will 4 go into 7? And the answer is 4 only goes into 7 one whole time. And how many fourths do you have left over? Well, you have 3 more left over. So 1 3/4. We've just changed it back again. Section 5.1 shows using models to add fractions. So here we have a models of our blocks, our pattern blocks. Now, keeping in mind this yellow one represents the whole thing. Okay, so yellow, this whole thing here, this is one whole. Now, I'm going to shade in 1/2 of it. So now I'm going to add up my fraction. So I've got 1/2 plus 5/6. So I took this yellow whole and broke it into 6 equal pieces, and each piece is this big. So now I'm going to take 6 of these and make sure it's on my yellow whole. So now I want to add them together. So what I'm going to do, I'm going to take my pieces over here and I'm going to add them to 1/2. So I'll put him there, I'll put him there, and I'll put one more. I think I'll use this guy. There we go. So now, here's what I've created. I've created one whole shaded in. So one whole. And I have 2 pieces left, and it's out of 1, 2, 3, 4, 5, 6. So 1 2/6. Of course, you could reduce that in a simpler form. It could be 1 if I divide this by 2 and divide this by 2, I'll end up with 1/3. Okay? And of course, you can see that even if I move this over, it is going to be 1/3 of the whole thing shaded in. As you can tell right away, that is 1/3. Now, can we write an addition equation for this one? Well, let's look at the first one and write what we have. We have 1 shaded out of 2. What do we have here? We have 3 shaded out of 4. Let's put them together. Let's take our pieces, our fourths, and put them in over here. So we will end up with 1 whole shaded in, and then 1 piece out of 4 left.